Hey guys, today we are going to be coding this computer here, this redstone computer. I've done some videos on it before, so that way it can do a division algorithm where it can divide any two numbers. So we're going to do that, and I'll walk you through the steps you need to make this. So I'll walk you through my entire process from making the pseudocode to the assembly code to how I actually program it in here. The algorithm I'm going to use for this computer is a repeated subtraction. So we'll have a dividend here, and let's set that up to 15 to start with. And then we've got the divisor. If you don't know what these mean, the dividend is the number on the top of the fraction, and then like the divisors on the bottom. So this is the equivalent of doing 15 divided by 3. And then we've got the quotient, which is the output. So like this should be equal to 5. So we want that to be equal to 5 in the end. So how my computer works is it's only got a couple of commands. It can do addition, subtraction, loops, and a break if statement. So it can jump somewhere if a condition is true. So what we'll do first is we'll set up a loop. Think of this as like a while true statement. So here we've got a break if, and we're going to break if the dividend minus the divisor is negative. So this will do if the difference of them is negative. So essentially, if the divisor is bigger than the dividend you'll break, that's essentially what this means. And then here, we will do the dividend minus the divisor, and we'll set that to the dividend. So the dividend will equal the dividend minus the divisor, so we're just subtracting it off here. So for this example, the 15, let's say, would turn into 12. Then we'll increase the quotient. So we'll just increment that. And then, if this condition breaks, all we'll have to do is now we'll display the quotient. And then we'll have an end function here, which just loops over and over again, such that the code doesn't like freak out when it runs out of code. So this is what we'll need. And to make this into ASM, or assembly code, we're going to have to modify it a bit. So here's the end product. It's only 15 lines of code, and I'll walk you through what everything here does. So here, memory 0 equals 15. This is where we're setting the divisor. Setting the dividend, sorry. And then here is where we are setting the divisor. And then this is the quotient from before. So here we've got M0, which means RAM address 0. So think of these as like variables, and my Minecraft computer has 16 of them built in. So you can have up to 16 of these. A is the memory address register. So it will point to this. So when we set it to 1 here, it means we are pointing at the quotient. Now the data register is a register that holds data in an easy to use way, and we can do maths with it. So here we're setting setting D to M, sorry. So how we're doing this is we are setting D to M, but since A is 1, we'll be setting it to M1. Now B is our jump register. So we've got these jump commands, and it will jump to the instruction address of where it is. So this is set to 12, which means we will jump to this part here. It says 13, but that's because this starts from 1, where our code starts from 0. So we will jump to this line here. So jump reg set to 12. Here we're pointing at the dividend, and here this is the break if statement from before. So this actually does these two lines in one line of code. So here we're setting m, so that is the dividend since a is 0, to be equal to the dividend minus d. And d, as you remember from before, is m1. So here we are doing the dividend minus the divisor. And it's actually minus equals. So we're just subtracting the divisor. And here, sorry, that's wrong. We're jumping if it's negative. So that's what this line of code here means. It means if the result of this is negative, then we're going to jump, and we're going to jump to here. Now we're setting a to 2, which is pointing at the quotient. We're adding 1 to the quotient, and here we're setting the jump register to 3, and then we're jumping, which takes us back up here, and we're going to repeat this until this becomes negative and we jump down here. So down here we're setting a to be equal to 2, which is going to be the quotient, and then we're saying the display is equal to the memory, which is the quotient because a is equal to 2, and then we're jumping, which jumps us back up here, and then this just loops constantly, so that way the code ends in a nice way and we don't run into any problems with like it going beyond the length of the code. Okay, so here we've got the computer, and here we've got the memory for it. So this is the read-only memory, which is where we store the instructions, which are carried by these redstone torches. So here we've got this row here, and this is line 0, line 1, line 2, up to 7, and then here's 8 to 15, and so on, all the way up to the end. Here, this first line has code in it which says set memory address 0 to 15. This is 15 in binary. And this one here says set memory address 1 to 3. And as you can see, this is what we had in assembly code. It's the exact same thing. So it's the exact same code, just written in a different format. Okay, so in order to run this code, we need to flick this lever, which starts this hopper clock here, and then we can see the code running. So here you can see this is counting what line we're on, and it's increasing. But here you'll see it loops back around, and here I'll just wait a second, and you should see this eventually turn to 5, because 15 divided by 3 is 5. Okay, and as you can see here, we've now set the value to 5, so we're done.